For a horn and light, an audible visual meter, when you perform a battery test, our tools primarily have a test position. Some of them, you just take the toggle switch on the back and hold it. Our tools, like I said, have a test position. So for a horn and light tool, you want to hear the horn. You want to hear the horn and see the light. If you're not hearing the horn and seeing the light, you want to get the battery swapped out. Our tools in particular, they have a live line tool fitting on the front. You just unscrew it with a adjustable wrench, get the 9-volt battery out of it, get a fresh one out of the pack. If you get a fresh battery in the tool and the tool's still not giving you a light and a sound indication, you want to get the tool tagged, get it sent back to us if it's our tool, get it sent back to the manufacturer and get it out of service. All of our tools, no matter how old they are, we'll repair them. So we've got some tools that are around 30, creeping up on 30 years old now, and we'll still repair those tools till this day. Real quick, for an analog tool, I'll give you what you should expect from an analog tool. Again, some of these tools will have a test position. Others, you just flip them and hold them to the far setting, and they've kind of got a spring-loaded setting. But for an analog tool, you want to see a deflection of the needle. If you're not seeing any deflection or the deflection's weak, same thing. You want to get a new battery in the tool. You want to get the tool tagged, or you want to recheck. Sorry about that. You want to recheck the tool. If you're still not seeing a good deflection of the needle, same thing. You want to get the tool tagged, get it out of service, get it sent back to the manufacturer. For a digital tool, which is what a lot of folks are starting to move to now because of the accuracy. People are realizing the accuracy of these tools. They'll have a test position again or a spring-loaded setting. You just flip and hold. Like I said, these tools have a 9-volt battery. So you see this tool is reading 7.1 volts. We recommend for all the digital tools, if you see below 7 volts, go ahead and get a new battery in it. And again, just because you see that the battery's good, it doesn't mean the tool has had a proper test. And again, we'll go into that, how you test the tool properly here in a bit. But first, I want to talk about the basics of how a corded tool or a non-corded tool, wireless tool, how a voltage detector actually works. First off, you want to always use a tool that's direct contact. All of our tools have direct contact. Some of them have a proximity setting for just an approach, but whenever you're testing your voltage for energized or de-energized, you want a tool that uses direct contact. So the direct contact tools, how they work, regardless of manufacturer, is they make contact. The tool, the components in here that are conductive, that make everybody's tool work, those components couple with the capacitance that you're working with, making contact with, in relation to the ground. So for a wireless tool, like I said, it has to couple to the ground wirelessly. So it's actually doing that through the air. So in order to make a wireless tool more accurate, what we do is we actually put a scale on the back. It's not a voltage setting scale, but what it actually is you're telling the tool how far from the ground plane you're working. So for URD, OH, and OHT, URD is underground residential distribution. So you're telling the tool that you're working close to the ground plane. So the ground plane can be the ground itself or a grounded structure nearby, within 0 to about 10 to 15 feet of a known ground plane. So again, so the ground plane itself or a grounded structure. OH, for overhead, you put the tool on overhead, you're telling the tool that you're working about 15 feet up to about 35 feet from the ground plane, whatever that ground plane may be. And then OHT, overhead transmission, you're telling the tool you're really far from the ground plane. That's the most sensitive setting of these tools. So the tool, again, it has to wirelessly couple to the ground. So each time you scale this tool up, it's going to be more sensitive. So if you use the tool in the wrong setting, or if you don't realize the particular scenario you're in, say maybe you're in a substation and you're using the tool in OH because maybe you're 20 to 25 feet off the ground. But even though that potential's high in a sub, there's a lot of nearby ground planes. There's a lot of grounded structures. You may find with a wireless tool you want to use this tool in the URD setting. It'll make the tool more accurate just because this tool is no longer looking at the ground itself, it's now looking at the grounded structures that are nearby. So now that you got a basic understanding, since like I said, everybody's tools have conductive components, we'll talk about some tool safety. So what we do as a manufacturer is we put resistors in the probes. Those resistors, they protect, again, those conductive components and you guys being the user. So we put about 25 mega ohms of resistance. Some other manufacturers only use about 6.5 mega ohms. So what we also do is we encapsulate those resistors in this probe in an epoxy. That epoxy keeps out any type of outside atmosphere. The outside atmosphere, if you start getting water or dirt, grime inside these tools, what that could cause is a track to those conductive components. So that eliminates any of that risk. So since the tool's sealed off inside, what you then want to worry about is keeping the tool externally. You want to keep it clean on the outside of the tool. So if you get any stickers on the outside of the tool, dirt, grime on the probe, what that could cause is a track to those conductive components if you're using the tool improperly. If you're using the tool properly, a lot of times it's not going to matter. But if you start using the tool unsafely or improperly, then that's when you can start seeing some issues. But what we do is, I think is it OSHA or ASTM? Who recommended that?
ASTM.
ASTM recommended putting a line limit mark on the probe. So that line limit mark, it's a recommendation of where you don't want to bypass on this tool with a potential or a potential ground plane. So for that same reason, since there's conductive components in here, say you're making contact with a potential at the probe tip and nearby there's another potential or a ground, you start getting close to this meter housing, what you can see is an external flash to those components. A lot of times it's not going to hurt the tool, it's just going to create a path, from either conductor to conductor or conductor to ground. So just improper work methods, Brent will go into more depth on that. Another thing I want to talk about is using accessories on the probe tip itself. So you can make direct contact with the probe tip itself, but what we always recommend is not to take shortcuts. We recommend using the accessories on the end of the probe tip. So maybe you got a point source, use a straight probe. Maybe you've got an overhead line, use a hook probe. What these accessories do is they just better your depth perception. So say you're working and it's rainy, foggy out, maybe it's nighttime. You want to put one of these accessories on the probe tip. Say you're working overhead and you put this thing on an extendo stick. It just gives you a better chance of not bypassing that line limit mark to start encroaching on those conductive components. But I think that's the basics of what we'll talk about. We'll go ahead and get started with the actual training here.
All right, you guys still hear us well? Good. So what we're going to do is we're going to talk about some details here that are extremely important. And your line workers, your linemen will always want to keep this in mind. Always know that every one of you all are super important and you have great purpose, and you're going to influence a lot of folks around you throughout your career, throughout your lifetime. And a lot of these influences aren't spoken, they're just trained by your actions. So it's important. Ryan was talking about not taking shortcuts, not using an accessory. A lot of folks don't use an accessory, they'll just use the tool and reach out and make contact. And it's so important that you use the proper accessory. You're gonna see some of the guys, maybe a line woman, all right, out in the field not using the proper accessory. And you guys need to stop them and say something. And a lot of these guys take these shortcuts maybe 20 years into their career, and they're fine. But you're going to hear some things today that guys are getting hurt from out in the field because they're handed a voltage indicator, they're handed a phasing tool, wireless or corded, and you know, they're nice and new and shiny. There's no bruises, there's no dents on them, and the linemen aren't trained on how the tools even work, regardless of manufacturer. They're just handed the tools, and they don't even know how they work. So we get calls on arc flashes, near misses, incidences that are taking place because the guys get a tool to protect them and to verify voltage, to verify they're in phase or out of phase, but yet they're not trained on how the tools even work. That's amazing. It's hard to believe, but it's true. All right. So what we're going to do is we're going to take care of some of that today as far as functionality. So when you're using these tools, a lot of the guys, we go around the country, we're training, what they're doing is they're using the tools maybe in their gloved hand. Maybe they have capacitive test points on their elbows. They're going into a cabinet and they're using these tools with a gloved hand. So we're going to call this tool gloving, all right? And if you're a lineman, you don't want to have a nickname tool glover. I mean, think about it, right? So you don't want a nickname tool glover. So you don't want to do this right here. Remember how these tools function. Just remember this. So what happens is we've got an X. We've got an X, and that's going to be the conductor. The conductor itself is X. Whether or not the conductor, long source, point source, whether or not that conductor is energized or de-energized, that is the X. Plus Y. Y is the tool functionality. So X plus Y, how the tools function. Remember, they make contact with the conductor, X. The tools couple with capacitance. The tool is looking at the current, as Ryan spoke earlier, in relation to the ground plane. And then the tool looks at the current and gives you a voltage indication, all right, on the display, whether it's a horn and light, whether it's a digital, whether it's an analog tool, whether it's wireless or corded. That's how they work. It looks at according to the ground plane. If it's wireless, it's going through the air like Ryan said. If it's corded, it's using the cord, and you have a direct relation to a ground plane nearby through the cord. But the functionality is still the same. So if that's the case, that means that everybody's tools, when they're out and using them out in the field, the tool itself is energized. Think about it. The tool is energized. It has to be energized, regardless of manufacturer, in order for the tool to function properly. So tool gloving right here, the tool's energized, and I'm tool gloving, and look at this ground plane. Look how close this ground plane is right here. So we're going to get false positives. We're going to get false negatives. So this is improper body position, obviously, and this is not proper work methods at all. This is a completely unsafe practice. Completely unsafe. So equals Y. Equals Y. Equals Z, safety. So X plus Y, conductor plus tool functionality equals safety and information gathered. So if a lineman's out in the field tool gloving, he's not getting proper information gathered because his readings are going to be skewed. And then it doesn't equal safety at all as well. So this is very unsafe. Also, another nickname that a lineman doesn't want to have when he's working out in the field is short stick. I mean, just think about that. You don't want to be called short stick. And this right here is very dangerous as well. Again, false positives, false negatives, skewed readings. So it's just not safe. You don't ever get equal safety and accurate information gathering at all. Because what happens is X plus Y, now you're entering into the equation of X plus Y plus U. And when you enter the equation of X plus Y, you never get safety, ever, period. And you don't get accurate information gathered as well. So we recommend a minimum of 31 inches back. We have our own sticks now, and we have our own hand guards. We're making them now. They're pretty nice. So what you got to do is you want to be a minimum 31 inches back. You're going to go ahead and put that hand guard where your work methods are trained and taught and written. So that's what we're going to do, and you're out of that equation of X plus Y. Okay? You guys have any questions? You guys get this so far? Capiche? Comprende? Okay, we're going to talk several languages once in a while just to keep you guys awake. Okay? All right. So what we're going to do here is we're back feeding these pad mounts right here. We got 3-phase power. We got 19.9, 34.5. And we've got a 120/208 panel. And we've got some 7200 overhead. So this is what we do around the country. Typically we use a generator, which is a little louder, but today we got some shore power, which is extremely rare when we travel. 3-phase shore power, but we do. So what we're going to do is, if you go to that 1910.269, that lowercase n, where it's talking about your temporary protective grounds, you go down to number 5. Number 5, it talks about how before you're going to install your TPGs, that the line worker, he's going to go ahead and verify an absence of nominal voltage, your system voltage, an absence. So that's what we're looking for. But we like to train it is we're going to look for an absence of nominal voltage, we're going to look for a lack of backfeed, and we're going to also look for an absence of induction. And we have the tools that are accurate enough to verify a lack of all three. You know, guys are getting hurt on induction all around the country. So we don't want the lineman to make contact with the TPG on the particular conductor when he's not verifying a lack of induction as well. And this should actually be changed. I believe it should be changed in the OSHA regs. They should be looking for a lack of all three. For some reason, it's not changed yet. But let's change it, okay? Let's work together. Well, what we're going to do is we're going to use this tool and we're going to go to our conductor. Let's call this an overhead line right here. All right, it looks pretty obvious, it's overhead. So what we're going to do is we're going to go to the conductor. Now, typically it's trained open, test, ground. The 3 steps, open, test, ground. What we're going to do is, how we train it is we're going to test, open, test the tester, ground. 5 steps. We're going to add a couple of other steps. Takes a little more time. Hey, the linemen are getting paid hourly, so that's good. But it's a lot safer. And we're going to be a lot safer. What we're going to do is there's 2 reasons why we're going to test first on that conductor knowing it's energized. Is by doing so, we're actually testing the tester on a live known voltage source right here. We're going to test the tester on a live known voltage source. So, before we open. But the second reason we're going to test before we open that switch, and to me this is the very, very most important reason, is because we must have mutual accountability. If I'm out with you out in the field, you deserve to know that I am mutual accountable to you. And I deserve to know that you are mutual accountable to me. Yeah, we did the tailboard. We got the cones out. We got all the risks, all the hazards. We got some traffic control happening. We understand what's going on. Hey, we might be in Florida and we got to look out for the gators and moccasins too. And that's okay. So we understand all that. But the biggest reason is mutual accountability. So we got to be professional. We got to verify mutual accountability. So we're going to go ahead and test on that overhead line prior to opening the switch. So we're going to go to URD, because this overhead line happens to be pretty close to the ground plane, right? Underground residential distribution. So the tool discriminates. So it's going to be more accurate. We're the only manufacturer that does that. That's kind of cool. But what we're going to do is we're going to make direct contact. You guys, you got to get in the shade, us, Ryan.
Yeah, go ahead.
Huh? You are? Good. You guys see those numbers? They're not making any movement. Then that's what you want. It's important you guys use direct contact tools. A lot of utilities, they give their guys non-contact tools. And by giving them non-contact tools, let's say we have an underbuild. The linemen are going to be presumptuous. They're going to be guessing. Well, is there induction on that underbuild or not? You really don't know. Shoot, we got non-contact tools out here 2 feet away from 19.9, 34.5, and we're getting 69,000 volts. Well, which line's hot, which line's not hot? What's the induction? Is there backfeed? You just don't know. So you want to have direct contact tools, always. Direct contact. It's reading a little high today, isn't it? So anyways, this is 19.9. It's reading about 40,000 volts. We got a floating ground somewhere. Sometimes it's accurate, sometimes it's not, but it'll work. So anyways, we got direct contact, and we're verifying that conductor is energized. We're also verifying that your head's in the game. All right? We're using a live known voltage source. The tool's working great. Then we're going to open the switch. We open the switch. We verify that we have an open air gap. We verify we have visually the switch is open. And then we're going to retest on that overhead line. We make direct contact, and the tool says we are de-energized. All right? So now the tool tells us we're de-energized. The tool is accurate enough, and we're confident that it's telling us we have a lack of system voltage, we don't have induction, and we have an absence of any backfeed. But how do you know the tool was functioning properly? How do you know that it was working and was accurate? So now what we're going to do is we're going to test the tester. We have a handheld power supply right here. Puts out some voltage, high frequency. And we have a 3 kV power supply right here that you could use it in your kits. So we're going to test the tester. You all see that? Good? Everybody here? Okay. All right. So now we verify that the tool is accurate. We have a lack of all 3 voltage types. So we can put our TPGs, we can place them now. Set up our EPZ properly and safely. 5 steps. We're going to test, open, test the tester, put on your grounds. All right? All right? Good? All right. You can put that back on that tripod just for a second if you want. All right, so it's important. We get one of the calls we get as far as regarding a manufacturer's tools, an incident, a near miss, is arc flash. And the reason why we get these calls, probably regarding incidents, more than any other call, and most of them obviously are going to be post-incident, and we have to travel and do some post-incident training. So it's important when you're using these tools to always remember that that tool is energized. If you have a ground plane, if you're going to visually inspect your work area and you have a ground plane in close proximity to that meter, you have a high potential of an arc flash. That's pretty obvious because now you know how these tools work, corded or wireless. It's the same. The tools are energized. They have to be in order to work for you. So you do not want to have another potential, another hot phase nearby. Maybe you're in a substation, all right? Maybe you're in a tight vault and you've got a ground plane. You've got the cabinet itself possibly. Maybe you're using the tool like this, and here's the cabinet, the edge of the cabinet, and you can see that if for whatever reason that tool turns in that bushing, we're going to have an arc flash right there. You guys see the difference? So it's important that if you have that scenario, that you use a 0 ohm extension. You simply place that 0 ohm extension onto your meter, that cone tip, the probe, and then you can see by using that 0 ohm extension, you're going from here, that potential arc flash, or you got a hot bus here, you go from here, now you're here, and you will never have an arc flash. So you're not going to use a 0 ohm extension all the time, obviously, but it's good to have one in your kit, so when you have that scenario, once in a while, that you have that protection, that device, that accessory. So let's see the difference now. All right, you guys see those numbers are a little lower now than they were. We were reading over 40,000, now we're reading under. All right. Two things have taken place with the zero ohm extension that are different, physically different than they were without the zero ohm extension. Two things. What two things are they? You guys, I'm asking you guys a question. What two things have taken place? Two things have changed. What are they? Physically. Okay. Yeah. Yeah. So two things have taken place. We're further from the source with the meter head, and the meter head is further from the potential ground plane. So the meter is going to be more accurate for us. You all see that? A lot more accurate. Okay? So it's important that you use a zero ohm extension. If you're phasing and you've got three hot bushings close side by side with each other, and you've got the cabinet nearby, what's going to happen is those other phases are going to influence that tool somewhat. Let's say you're wirelessly phasing. Let's say you're looking at voltage. That meter head's going to react with those other phases, and it's going to create skewed numbers, not accurate numbers. Okay? So let's talk about proper body position real quick. So proper body position, we get a call from Illinois, and the guy in Illinois, lead lineman, said, hey, your analog tool, it's no good, your analog tool sucks. And he said that he's getting 13,000 volts. He's getting 13,000 volts on 7200. And they've had the tools for 5-6 years, and now the lead lineman's getting inaccurate readings. So he's on 7200 and he's getting 13,000 volts, and automatically I know what's going on, and you guys should know what's going on. He's got improper body position, period. It has nothing to do with the tool at all. So I'm not going to argue with the guy, so I simply get a plane ticket, fly out, and bring some tools and do some safety and tool training like we're doing here today with you guys. So what happened was we did the training indoors. He understood how the tools work finally. We go back outside, he goes to the same scenario. All right? And when he goes to that same scenario, here's a corner pole. All right? This is a corner pole. And this corner pole, as you can see, has some lean to it. That's because it's from Mississippi. Okay? A lot of the poles in Mississippi, they got some lean to them, so that's where this pole comes from right here. And what happened was, when he called me, he was in that bucket truck, and he was short sticking the tool right here. He was short sticking, and he had his back to that potential behind him in the bucket truck. All right, so first of all, this potential right here is a blessing, but it could be a curse. So it could be an enemy. It could be. So why would you put your back to an enemy? Huh? Why would you do that? So what he did is, after the training, so he was short stick, right? And he was coupling with that capacitance behind him through his body. That capacitance was flowing across his gloves through the tool this direction. The conductor he was making contact with was that potential was flowing through the tool this direction to ground. So what he became a living, breathing phasing tool. Okay? Right here. Living, breathing phasing tool. But after the training, him using his broke tool, gets in his bucket truck, he simply repositions himself. Same location. Same location. The tool hasn't moved any distance from that potential, but his body did, and his hands are back 31 inches or more behind his tool. And what happens is he's getting 7,400 volts using an analog meter on 7,200. So he's getting accurate information. And the reason why is because he has proper body position. Proper body position. All right? It's important. This is improper body position right here in two ways. I'm short sticking and my body's close to that potential. And I know I couple with capacitance when I'm in the field because I'm a lineman and I work with this stuff hot. Hey, I'm coupling with my work somewhat. We're going to show you guys that in a minute. We're going to measure that. We're going to prove it. So if you're working on an underbuild, or you got some close wires to each other, and you got a horizontal stack or a vertical stack, what you want to do is you want to come to that potential with your tool, and you want that tool to be perpendicular, 90-degree angle with the conductor you're touching, let's say the long source here, with the conductor you're touching, and a 90-degree angle as much as possible from the other conductors above and below. All right, and that way the meter head is not being influenced by the capacitance on these other conductors, the corona, that field. All right, if you've got a ground plane, maybe you got a corner pole, all right, from Mississippi, you got a corner pole with a ground on it. You don't want that meter head close to that ground. All right, it's gonna give you a funky reading, just skewed. All right, so it's important. If it's a horizontal stack, the whole thought process is exactly the same as the vertical. All you got to do is just turn your head sideways a little bit and figure it out. Okay. You guys good so far? Any questions?
That's good.
Okay,
No,
good.
sir.
All right. All right, just making sure you guys aren't asleep. All right, so what we're going to do is we're going to come to this potential. All right? And what we're going to do is Ryan, you want to tell them about the PD25? Tell them about what you're going to do with it, how the tool works.
Yeah, so the PD25,
Right here. There you go.
it's our corded voltage meter and phasing tool. Again, PD25 reads up to 25 kV. You can put extension resistors on it. Reads up to a PD70. It'll be a PD75 up to 75 kV. But what we're going to do is we're going to take some readings on across Brent's body when he's using proper work methods and also then improper work methods. So let me.
What are you guys giggling for? All right. Ready, Ryan? So this tool here is one of Walter's patents. This tool here is true RMS voltage plus or minus 1%. It's extremely accurate. We call it a multimeter because of its accuracy. You can do many things. It takes the place of many tools, and the cord is shielded. We're the only manufacturer that actually customizes the cord that the tool uses. Only ones, and it's shielded at 35,000 volts. It can lay on the ground when you're using it. You can inadvertently brush up against it. It can lay on a metal box when you're using it because the cord is shielded. So the cord's very safe. But again, it's corded. So because it's a part of the tool, your work methods need to be written and trained that you need to be how many inches, if it's 31 inches, 36 inches from the meter, when you're working the meter, you got to also train and teach that they're 31, 36 inches back, whatever you have, from the cord. Even though our cord's safer. We're a family company and we can do what we want. So our tools, we make them a little safer. We can put that resource in. We don't have stockholders. Okay? So anyways, okay, Ryan, go ahead.
So first I'm going to show you some readings when he's using the tool properly. He's working back on his stick. So on his foot, and actually just in the air, we're picking up about 9 volts. Go to his back, across his body about 14 volts, and then we'll go to his glove, and we see 22 volts. It's important to remember these numbers.
Okay.
Now we'll show you using the tool, or short sticking, using the tool, holding it in properly, coming in close proximity with the meter head.
Okay, remember y'all, you don't want this nickname short stick. Okay?
So remember before, and we see right here, picking up only about 7 volts through the air. Go to his foot now, where it was 10 before, we see about 37 volts. We go to his back, and we see 46 volts now. We'll go to his glove, and we see right at 70 volts, 71 volts. So already you see he's coming in close proximity to that meter, and as he gets closer and closer, those readings will go up. So now he's going to simulate what it would be like if you're actually holding the tool in your gloved hand. So again, remember before, seeing about 8 or 9 volts out here. Go to his foot, where it was 10 volts on his foot. Now we see about 114, 115 volts. Go to his body, see about 140 volts. And on his glove, front gloved hand, now we see about 226, 227 volts.
Y'all see that? Okay, that's real. That capacitance, when you're working hot, the linemen are literally coupling with capacitance, measurably so. This is real. This is exactly what happens. This is how the guys are getting injured, because they think they're isolated. I've got a good friend on. Okay, I got a good friend. I was doing some training in Florida last winter. That's usually where I like to be training, and obviously in the winter is in Florida. All right. And I was doing training, and every day the linemen would go out of this particular service center, and there was a big sign that they would see driving out with their bucket trucks, with their line trucks. And that sign said, your TPGs that we were talking about over here are your best friend. And your gloves are a best friend. That's not true. I told them they needed to change that sign. Your gloves are a good friend, not a best friend. So if I'm working, if I have proper work methods, proper body position, what happens is I am keeping my other best friend that you all need to always remember to keep and guard and protect. And that best friend is called the air dielectric. Right here, that air dielectric. That is a best friend. When you're short sticking, or if you're tool gloving your tools when you're using them, you're literally kicking your best friend to the curb. And a lot of guys, that's what they do, man. For 20 years, they'll go out there and short stick. I get this all the time. And they're kicking their best friend to the curb. I was doing training in California a couple years ago. And after the training, one of the linemen came up to me. He was like 25-year journeyman lineman. And what happened is when he came up to me, he said, "Hey, that tool gloving that's pretty important." He says, I was tool gloving with my gloves for decades. Think about what he's telling me. For decades. First of all, this is completely unsafe. And this is what he's doing for decades. And then one day, he decided, out of the blue, think about it, 25-year journeyman lineman, out of the blue, that he's going to not wear his gloves. He goes to a capacitive test point, not without any gloves on. Well, you know how these tools work. So what do you think he told me what happened next? What do you think happened? What do you think he said? Yeah. He got popped with about 300 volts. Close to 10% of your system voltage on the capacitive test point. He got popped. So that's a shortcut. But I tell you, us guys, sometimes we get so complacent and we think we're invincible. So not only do we tool glove, but we'll just leave a good friend to the side. We've already kicked our best friend. Now we're going to kick a good friend away too, our gloves. So that's exactly what happened. So it's important that we have mutual accountability. We got to watch each other. We got to be our brother's, our sister's keeper. And there's so much bullcrap in everybody's head that people aren't doing that. I was doing training in Michigan several years ago. And sometimes this training is post-incident. And I don't like post-incident training. But anyways, there was an incident in Michigan. And what happened is two guys were out in the field working. They were working some overhead hot. And they were changing out a broke pole. And what happened is one guy was using the boom, pulling the log out of the trailer. The other guy was in the truck grabbing some gear. And what happened is the guy that was using the boom made contact with the overhead line. At the same time, his buddy, 20-year journeyman lineman, was getting gear out of the truck. So the lineman, for a split second, became aground. And that potential wants to go home. And if you're going to allow it to go home through your body, that's what it's going to do. And in a split second, his wife lost him. His kids lost their dad in a split second. Done. There's no second chances in some of these situations. So what happened was the guy working the boom had no mutual accountability to his brother in the truck. And his brother in the truck had no mutual accountability to the guy in the boom, because it works both ways. Because you don't want the guy in the boom to live with the fact, knowing that his buddy, his partner, is dead because he didn't have mutual accountability to his partner. And the guy that was in the truck needs to have mutual accountability to his brother in the boom, so he doesn't have to carry that weight, that burden, the rest of his life. So it goes both ways. There was a situation where a guy was working in a bucket truck, and he was coming up to the high line. What happened was his bucket truck on the way got caught up on the communication cable. The low line got caught up. And the bucket truck, when it got caught up, he was working the hydraulics trying to get it loose. And what happened is when he was working the hydraulics, that bucket truck came loose and shot up to that next energized line just above him. He lost his whole arm. His whole arm's gone to this day. He survived, but he lost his arm. All right? So what happened was his buddy was in the truck shuffling papers. He didn't have mutual accountability watching the guy in the bucket truck. The guy in the bucket truck didn't have mutual accountability to make sure his buddy was watching him. Both of them. No mutual accountability. All right? So you guys... So we were doing training in Tennessee. When we were doing training in Tennessee, Murfreesboro, just south of Nashville, two linemen came up, and we were doing this open test ground on a pad mount right here. Training, week training. We were using this as a station, but of course we were training at test, open, test the tester, ground. All right, that's how we train every time. And they said that one of the guys got an arc flash. And what happened was there was two guys working a cabinet. In the cabinet, one guy was on a stick working the elbows. They were working hot. They knew it was hot. He was on a stick. And you can see I got the air dielectric. I'm working the elbows. I got an air dielectric. That's my best friend. But the cabinet was loose from its foundation. So make sure you have a good foundation in your life. That's important. Well, the other guy realized that he's having a little trouble working the elbow, so he walks over to the cabinet while his buddy's on the stick, and he takes his good friend, his gloved hand, and he puts his gloved hand onto that cabinet. And when he did, he got arc flash instantly, right to ground. He got burned up, spent some time in the hospital, he's fine. But that arc flash will be a scar on your mind forever. It is, whether you witness it or whether you are a participant of that arc flash, you're going to always have that scar on your mind forever. Okay? So what they did is they wrote up in the incident report, the reason why he got arc flash is because of rat piss. And I told the linemen that were there in the training that that's not true. That was a escape rat. All right. And what happened was when that line worker went up to that cabinet to steady it for his partner, he kicked his best friend, the air dielectric, to the roadside. Trusted a good friend. He got arc flashed. He coupled with the capacitance a little too much. He crossed a red line. And when we're working hot, there's red lines all around us. That's why we got mad. Minimum approach distance. If I take off my gloves and I touch that 120/208 panel behind me, I'm gonna feel it. And that's crossing a red line. All right? And those red lines, the higher the potential, obviously, that and influences from other potentials or ground planes, that red line starts coming at you. Environmental, we had some dew this morning. So our environment's a little juicy. If it was foggy, our environment would even be more juicy. So we're gonna have these red lines coming after us, coming towards us closer and closer. So I told those guys that he just coupled with the capacitance just a little too much. He crossed a red line, he got arc flashed. So you guys see these numbers? You ready, Park? You wanna stand in the... Got it? All right, you guys see those numbers? All right, now watch what happens with these numbers. What are they doing? Can you see the numbers? Can you? Now? Yes?
Yeah.
Okay. All right, what are they doing? Climbing. That makes sense, doesn't it? You know how these tools work, right? That makes sense. That's right, I'm coupling with the capacitance. So what's happening if you're tool gloving or short sticking, what happens is these tools, everybody's tools, are calibrated. And they're calibrated such that there's no ground plane within 30 inches of them. All right, that's how they're calibrated, so they're accurate and they're safe. We don't tool glove when we calibrate these new tools before you all purchase them. We don't tool glove, we don't short stick. We calibrate them and we get away from the tool. So they're accurate for you guys and they're safe, give you guys accurate information. All right? So if I tool glove or short stick, what's happening is I'm telling the tool, which is this big right here, this big, that you're this big plus me big. Okay? And that's not how these tools are designed. You got these little birds on the line. These little birds land on the line because they're small creatures and they don't couple with the capacitance. Their bodies aren't charging in relation to ground to where they feel uncomfortable. Where the big birds do because they're bigger birds. About a year ago in Georgia, and some safety guys said, hey, that was pretty cool showing us the numbers climbing, but we got some, we have some overshoes. Brand new overshoes. About a year ago, we have some brand new overshoes. And we bet if you put these boots on, that when you do the short stick, show us the tool gloving, that those numbers don't climb. Think about it. The safety guys are telling me this. And I told them, I said, I'll tell you what, if we do this and those numbers climb and they're actually similar to with the overshoes as they are without them, can I have your boots? Can you just donate them to the training from now on? And as you can see, they donated them. So let's see what those numbers do. What time is it, guys?
11:09.
Okay. Tell me when it's about 9:20. I need to know. Okay? Because we got to wrap it up. All right. You good, Ryan? You want to reset it, maybe? Just in case. All right, guys. So we're just going to go straight to the tool gloving. Straight. I've got the overshoes on. All right? So, if I've got the overshoes on, what does that make me now? Okay?
Alright, so remember on the shoe before we were seeing right at 100 volts.
Get on the overshoot. There you go.
It's right around 90, 95 volts. Go to his body. We were seeing about 130, 140 volts. You see about 116, right at 120. And we go to his glove here. There you go. And what do we get for?
170.
About 170 volts. So really no change there. The only difference now is he's insulated at his feet and he's insulated at his gloves. So his body's actually building up that charge and his body's now a capacitor.
Okay. You all see that? Pretty cool, isn't it? Pretty sharp stuff, man. All right. You all have corded tools? You have any corded phasing tools, any at all?
Yes.
Okay. All right, good. So let's talk about some corded safety. So what we're going to do is we're going to use our PD25 and we're going to talk about some safety information gathering, how to do it properly. And first thing, you all have any capacitive test points on your elbows? Okay, good. So what we'll do is we'll do some phasing off capacitive test points. So we're going to go over to this left pad mount. That's a new address, left pad mount.
When using a corded tool, if you can use it to phase or take voltage off a test point, we highly recommend to do so because the potential there is obviously less, so it's a little more safer practice. But it's a little bit different from just phasing on a straight conductor. So what you're going to do here is, since each of these elbows cures different, each capacitive test point is going to have a little bit of different resistance value. So what we're going to do first is we're going to take a phase to ground reading. The reason we're going to do that is we're going to verify that the tool's working, we're going to verify that our head's in the game, and we're also going to take that number and we're going to remember it. Because like I said, each elbow is going to be different, so we're actually going to see the difference of the two values when we go phase to phase. We won't see zero, so we'll see the difference of the two. So here we've got right at 340 volts, and here we've got right at 260 volts, so about 80 volts difference. So when we go phase to phase and we're out of phase, we'll see that 1.72 multiplier, about 500-600 volts. If we're in phase, we'll see the difference of about 80 volts. So we see close to 75 volts, 74 volts. So not quite zero, but it's definitely, again, not that 1.72 multiplier we would see if we were out of phase. So we know here these two elbows are same phase. So we're just confirming the phasing there. This tool, accurate, starts working at 1 volt, so we can use it to phase the secondary panel. So here we'll go phase to ground first. It's a 12208 panel. We see 120 volts. We'll go phase to phase. Looks like in phase, so we see 0 volts, so this is in phase. Here we're out of phase, so we see 212 volts. And this tool also, again, goes up to 25 kV. So now we'll use it on the primary voltage here, 19.9.
You guys hear us good so far? All right. We're gonna have to, we got about 5 minutes, guys. We gotta wrap this up because Job's doing some training in our yard and he needs the equipment. Just go ahead and pan around there. Parker's showing you our live line training facility here, and Joe's going to be doing some training here in just a few minutes. So what we're going to do is we're going to go over the primary power, overhead, underground, it doesn't matter. Show you guys.
So again here, primary voltage, we're going to go phase to ground first for the same reasons. We're going to verify the tool's working, and we're going to verify our head's in the game. So make contact. We get a 1 at first. So I've still got this tool in the secondary setting. It's in the 2 kV setting. We get a 1. It's telling us that the tool's in the wrong setting. It's not actually broken. It's just giving us a funky reading to let us know it's in the wrong setting. So flipping to the 25 kV setting. Again, phase to ground. And we see about 20.6 kV. So with this thing using our trailer as the ground, it's got a good ground reference. So if the ground in the transformer was hooked up correctly, you know, that's what we could have been seeing there with the wireless tools. But here we go phase to phase. We're in phase. We don't quite see 0. We see 0.3. The reason for that is the cord's laying on wet grass. So there's a little bit of bleed in the cable. There's nothing wrong with it. It's just going to bleed off the ground a little bit there. So anytime you're using a corded tool to read voltage to phase, or especially if you're high potting with a corded tool, is you want to take the second probe to ground first. The reason you want to do that is you want to, 1, lead off the capacitance if you're charging the cable to high pot, or 2, if you're taking voltage or phasing, you want to bleed off any capacitance between the 2 meter probes and the cord. So when you take it off, you'll see it takes a second to bleed down to 0. That's just because of the resistance in the probe. So once it's to 0, you know either the cable you're charging is de-energized and the capacitance.